Hello, I'm Sam Shelton back at Energy 101, and today we're talking about petroleum versus oil. This is an important topic that hopefully will help clarify a lot of issues that you run into in reading articles in the media and listening to television and etc. Because these two words too many times are used interchangeably, and the general public generally thinks that they're synonymous, petroleum and oil. Well, here's a perfect example. This one actually came out of the Energy Information Agency with DOE, but this one was a news blurb that came out not too long ago that talked about U.S. petroleum. Doesn't say oil, it says petroleum. Production surpassing Saudi Arabia and Russia. And I won't go through this whole chart, but it goes from 2008 on the bottom out to 2013, which is obviously an estimate because when I'm recording this, it's not the end of 2013. The bottom part is petroleum, and then we have natural gas on top of that. And the three bars that we see in for each one, 1, 2, 3. The first one is the United States, the second one is Russia, and the third one is Saudi Arabia. So, and the black is petroleum. But notice it doesn't say oil, it says petroleum. And so we were producing less oil than Russia and Saudi Arabia back in 2008. You move to 2012, which by the way is the time period for the data that I'm showing you throughout this course, because it was completed during 2013 before the 2013 data was available. But you look over here and you see we're producing about the same as Russia. Here's the U.S., here's Russia, and here's Saudi Arabia. Saudi Arabia is still producing more. They're producing about 11.5, but that's petroleum. And we're going to see what the difference is between petroleum and oil here in just a minute. But it's very key that you pay attention to what is when they're talking about petroleum and when they're talking about oil. So the question you might ask is petroleum oil the same? And the quick answer is no. You cannot use those terms interchangeably except maybe in rare instances. Oil, so what is petroleum? We know what oil is. We've talked about oil and defined it and talked about how much we produce and et cetera, et cetera. But we haven't talked about petroleum. So let's find out today what we're talking about with petroleum. What is petroleum? Well, petroleum is oil combined with natural gas liquids, which I haven't covered what it is, but we will here in just a minute, and biomass fuels, which right now, those are liquid fuels, which right now is essentially all corn ethanol. Ethanol made from corn. We are, as I think I've mentioned before, beginning to trying to develop ethanol production capability from cellulose. That's like wheat straw and corn stover, corn stalks, and wood chips, and wood residue, and etc. But petroleum is the combined number for all three of those put in barrels of oil. So that obviously in petroleum includes more than just oil. So what is natural gas liquids? Because that's the big one. Ethanol we'll see is a small one, but natural gas liquids we're producing about 2.5 million barrels a day of that, and producing about 6.5 million barrels of oil for 2012. Well, natural gas liquids are a byproduct of natural gas production at a well site. And it's made up of ethane, propane, butane, and pentane. Now you probably know what propane is. You generally barbecue in your grill from a tank of propane fuel that you buy at the hardware store somewhere and get refilled. Butane is also similar to propane. We use it in lighters and things. It's a little lower pressure to maintain its liquid nature. but we use those and kind of understand those. Ethane and pentane is primarily used in the chemical industry to make different things, for instance, plastics, polyethylene, for instance. So, but why do all these come out with natural gas? Because at atmospheric pressure, all of these things, ethane, propane, butane, and pentane, are gaseous at atmospheric pressure. But at the wellhead, they pressurize them, and when you pressurize the mixture, the ethanes, propanes, butanes, and pentanes condense out. They become liquid, and it's easy then to separate them from natural gas by merely compressing them, which they compress it to put it in pipelines anyway. So it's not an extra step, it's just part of the compression process to get it ready to put in the pipeline, and when they do so, these natural gas liquids, as we call it, NGLs, natural gas liquids, as I've stated up top here, you see that term used quite a bit, it stands for natural gas liquids. So what are ethanes, propanes, butanes, isobutanes, and pentanes? Well, if you're interested, there's the chemical formula for you chemical-minded people. Notice that butane and isobutane got the same formula, but this is an isomer of butane, and we won't get into the chemistry of that because this is in the chemistry class. But for those interested, that's a chemical formula for all those other liquids that at high pressure they're liquids. And by the way, when you get propane in a tank, it's at high pressure, and that keeps it a liquid. And notice that when you open the valve and let it come out to atmospheric pressure, it's a gas, it's not a liquid. So what are the characteristics of natural gas liquids? It comes out of the ground in a natural state, gaseous state, as I've already mentioned. The mixture is compressed to separate the NGLs, and natural gas will not liquefy by pressurization. It will never liquefy by pressurization unless you cool it. But at atmospheric temperature, natural gas will not liquefy with pressure. In order for natural gas to liquefy, you must cool it to minus 260 degrees Fahrenheit. And when you see liquefied natural gas, and that we're beginning to talk, that's what you have to do to export it across the ocean. You actually cool it and refrigerate it to minus 260 degrees Fahrenheit, which is an energy-consuming process of its own. So natural gas is completely different in the fact that it will not liquefy with pressure at atmospheric temperature, whereas these NGLs do liquefy. So here's what the production rates has looked like, and the trend from 1982, when we produced about 1.5 million barrels per day, and now we're producing almost 2.5 million barrels per day. We did in 2012. And the reason for that is that we're producing more natural gas starting back about 2008, and you get the natural gas liquids with the production of natural gas. So if you produce more natural gas, you'll produce more natural gas liquids. So that's why they've increased, and they're becoming, notice we said that in 2012 we produced about 6.5 million barrels of oil. So 6.5, well, we're already producing 2.5 million barrels per day of NGLs. So it's a significant number. When you add them together, when you add natural gas liquids to oil, it obviously makes petroleum a much bigger number than just oil. And so we want to look at the appropriateness of that, or whether that's meaningful or not. This looks at the combination whereas the last slide only looked at natural gas liquids. This looks at the oil production from 1982 to 2012. It looks at the light gray or light blue, which is the natural gas liquids. And then the other thing that you noticed in my definition of what natural gas liquids were is that they're the biomass or corn ethanol. That's the yellow. And so here's the corn ethanol right here, and here's the NGLs right there. And this is the ethanol, and this is the oil. And so you can see it's getting to be a significant percentage of the oil that of the petroleum that we're producing, because it's a significant percentage of the oil that we're producing. So that's what natural gas liquids are, and those are the trends. But here's how the natural gas liquids are used. These are national averages for the makeup of natural gas liquids. They're about 40% ethane, as we see here, about 40% ethane, about 30%. I like to round off. I'm not going to get in arguments about whether it's 28 or 30 or 42 or 40 or 38 or 45. That's not meaningful for our discussion here, for the points that we want to make. Butane's about 10%, and isobutane's about another 10, so that's 20%. You add the butanes together, it's about 20% butanes, and then about 14% pentanes. And what are they used for? Well, ethane is used for plastics. Polyethylene bags, plastic bags, is made from ethylene and ethane. Propane, as I've noted here, it's used in home heating some, rather than natural gas. When natural gas is not available, it's more expensive. Therefore, if you have natural gas, you're going to use it. But if you don't have it, then it's, you use the propane a lot. Used in grills, as I've already mentioned, and liquefied petroleum gas. Even there are some cars that have run on it. That seems to be diminishing. The butanes are used again in the chemical industry for synthetic rubber, lighter fluid, and liquefied petroleum gas for cooking and cigarette lighters and things. Isobutane chemicals, and it's used in gasoline refinery to adjust the octane number and to get the blend that they want. And about 15% butanes, which again is used in some gasoline production, and of course, which means that's used some for transportation. So that's the utilization of the natural gas liquids. So in order to add them together for that to mean anything, oil and natural gas liquids should be the same. Well, are they the same? Well, if to be lumped together, is only appropriate if they displace each other, and you can use them interchangeably. Well, that's just not the case, particularly on a one-to-one basis. Now, some of them some of the natural gas liquids are used in the chemical industry, and so they don't have to use natural gas or oil. So it may replace some oil. But the general estimate that I think is about as good as I have seen or can figure out for myself is that 1 barrel of natural gas liquids displaces probably about 1/3 of a barrel of oil. It's in that vicinity. I think it's less than a half and probably more than 20%. But, and you can debate it in between that. But I really think that it's misleading to add the natural gas liquids and the ethanol to, particularly natural gas liquids, just to stay with that, to oil, and talk about it as a whole and put out news releases based on that summation, because it can draw you to misleading conclusions. So if you look at the liquid petroleum imports rather than oil imports, we've been looking at oil imports before. This is the first time we even talked about petroleum. You can see that it looks like it has gone down significantly since 2008. We started producing more natural gas, and that's one thing. We have produced more oil. That's helped at the drop, but we've also produced more NGLs, and that's helped at the drop also. So, but regardless, we're still importing about 50% of the petroleum, if you want to talk about it that way, which I never like to use the term petroleum because it's very confusing. Talk about oil or talk about natural gas or talk about natural gas liquids, but don't combine them. From a transportation fuel viewpoint, here's the pie chart that shows which transportation is the primary need for oil. And oil, of course, is used to produce gasoline. It's used to produce diesel. Now, ethanol does replace or displace oil almost on a one-to-one basis, but not quite, as we'll see just in a minute, because it doesn't have the same BTU value per gallon or barrel that oil does. But the other small sliver here that is a gray sliver, and you probably can't even make it out, it's got 0% here, but it's actually about 0.4%. It rounded off. It was below a half, and the software rounded it off to 0, but it's about 0.5%, call it. And that's different than the natural gas liquids. Ethanol does displace oil to a major extent on almost a one-to-one basis, or a lot more so than natural gas liquids. So that covers what we wanted to say about natural gas liquids. The next time we'll look at ethanol, since that's the other element that's in petroleum that gets added to oil. So let's look at the ethanol production and where it's coming from and what those trends are. See you next time. Thank you.